Okay, hello everyone. Welcome back to the basement. Uh, we're going to do chapter 6 here today, and I will have to read these problems through. I hope you have your copy, and we'll go through most of these. Some of these I don't think I have to do them all because it's repeating how to find the mean, median, and mode. So once you know how to do that, I'm going to show you how to do that on the calculator as well. So we'll see how it goes. And instead of doing all these, there's 19 altogether, so maybe I can cut it a little bit short and can get it concise. But I do have to elaborate on some of these vocabulary words that we're using in statistics. Okay, so bear with me while I try to explain what's going on in this chapter 6. All right, so we've got here's how it goes here for number 1. Decide whether each of the following statements makes sense or does not make sense, and explain your reasoning. So it's multiple choice, A, B, C, or D. However, it is a problem that says, I made a distribution of 15 apartment rents. Here's distribution. In my neighborhood, one apartment had a much higher rent than all the others. This outlier, our second word here, caused the mean rent to be higher than the median rent. All right, so we want to know what these words means in the context of this problem. So the distribution, any distribution in a statistics problem is the data that they're using. So a distribution here is going to be equal to the 15 apartment rents, whatever they're charging for them. So he's going to get like an average cost of that, okay, for the distribution. The average is the same thing as the mean. So whatever the distribution is of the 15 apartments, he'll take that and evaluate it to find the mean, and where mean is the same word as the average, what we know as the average. Okay, and then it goes on to say one apartment had a much higher rent than all the others. So if you've got a distribution of 15 apartment rents, let's say they're all, say $500. Maybe 450s in there, or a 475. All centered 525, all centered around 500 or so. I won't write all 15 up here, but you get the idea. But one of the apartment rents was much higher. So let's say the one other apartment rent was $900, and everything else was centered around 500. So it's just like, well, why is that 900 and all the other ones are around 500? So that outlier made the average of all the other apartments. Well, without the 10 million, the average would be 0. Okay, we can see that. The median would also be 0 as well. How do you find the median? Okay, the median is the middle number. You take your data set, I'll use this example for the zeros. You take your data set and you put them in order from smallest to largest. And when you do that, then you find the number that's in the middle. So in this case, it's the middle number, which is 0. So here I've got 5 numbers, right? 1, 2, 3, 4, 5. And so because it's odd, 5 is odd number, I'm going to have one number in the middle, and that would be this guy here. If it's even, if I had a 6 number here, let's say back here I have another 0. If I have a 6 number, then I would have to take one of the 2 middle numbers. If I have a 6 numbers, meaning an even number of numbers. So in that case, I do it this way. Cross them off, 1 for 1. Make sure I get that 1. And then I say, oh, I have 2 in the middle. So then you take those 2 in the middle, add them together, and divide by 2. So it's still, in this case, it's still going to be 0. Okay, but the focus here is if I have an odd number of numbers, I have one number in the middle, that's the median. If I have an even number of numbers, I got to take the 2 in the middle, add them together, divide by 2, and that's the median of an even number of numbers. Okay, the difference between the two. Okay, and so the outlier then is a much higher number, much higher or lower for an outlier. It doesn't have to be. In this case, it's the outlier is much higher because the rent was higher. Much higher or lower value than all the others. Okay? And again, that's in your book. I'm writing it up on the board. I don't want to do that. I want to cut down on the time as much as I can. So just to give you an idea here that the outlier is a much higher or lower value than all the other numbers. All right, and then we got the median. That's the middle number that I just explained here. And the average, then we know that from, a bowling or something like that when we were a kid. All right. All right, so that's our idea here. So back to the problem where it says this outlier causes the mean rent to be higher than the median rent. Okay, so let's think about that. Is the mean rent higher than the median rent because of this outlier being much higher? Well, the mean here of these 5 numbers, okay, is what? I add these up, 0 plus 0 plus 0 plus 0 plus the $10 million. That equals the 10 million, this 10 million. I'll rewrite it again and divide it by 5, the 5 numbers that we had. So the mean here, the mean equals 2 million. I'll write it up as 2M, 2 million. Okay, so we got the mean is 2 million. The median, well, we did this earlier and we said that the median was 0, the number in the middle. So the median here equals 0. So the higher outlier caused the mean to be higher than the median rent. True, that's exactly what happened here. And that would happen in any case. I'm doing a smaller example of that, and to prove and to show that the mean is higher than the median when you have a higher outlier than all the other numbers in the distribution. Okay, and so when you look at A, B, C, or D, our answer is going to be A on that one. All right, and that's number 1. And I've got to turn this off. Somehow.